this is problem 3, question 3 on Circuitry Worksheet number 2. So you guys have the questions on the worksheet. I'm not going to put them on the screen because I need the room to solve it. So before we solve this, like I was saying a moment ago before I started the recording, 30-volt battery, that's a delta V, right? So the best way to understand it, the positive plate, so the long one's the positive, the short one's the negative. All batteries have a positive terminal and a negative terminal. The positive plate would be 30 volt, the negative plate would be 0. So how many volts would there be, like right there? 0, because nothing's changed, right? The only time your volts will change is if you cross a battery or cross a resistor. Okay, so how many volts do we have over here? 30, right? So as we go, so the current comes out of the battery like this. Current is always positive charge motion. Current is capital I. The current comes down like this. Now, as the current moves from this point to this point, like right there, there's going to be a drop in volts. You know, and by the time we get over here, it's got to be 0. Does that make sense? And I'm just going to tell you, I'm going to like just tell you what this works out to be. This point right here, it turns out that this is 24 volts right there. So what's the delta V between those 2 points? From 30 over to 24. What's the delta V from here to there? What's the delta V? Nathan?
6 volts.
6 volts, okay? Now look, does it matter if the current that we're talking about is the current through the 18? Because what happens right here is the current splits, right? The current, this original current, so let's call this I1. This guy's I1. Now what happens to I1 right there? It branches. So we'll call this I2, and then this one right here would be I3, and then the one that goes down here is I4. Now, no matter which current you're focused on, whether it's the current through the 18, the 9, or the 6, what do all of those have in common? The delta V is what?
Constant.
Is 6, right? What's the delta V across the 18? 6. What's the delta V across the 9? 6. What's the delta V across the 6? 6. Do you guys see why it's 6? Because no matter which way you go, you know, think of it like you know, you're driving and, you know, there's a toll booth, right? So you go, like all these cars, instead of current, it's cars. Cars are driving through here. No matter which path the car takes, it's going to be going from 30 over to 24. So the change is 6 no matter how you do it. Does that make sense? They're hooked up to the same 2 points. You know, all 3 of these resistors are hooked up to the same 2 points, right? So they all have a delta V of 6. So then 24, now what's going to be the delta V across this guy? You can kind of figure, what does it have to be? 24 here, 0 there. What's the delta V there?
24 volts.
24, right? Because 24 to 0 is 24. Now, I just gave you these numbers. The thing is, you have to be able to figure them out for yourself. So let's do it. Let's do this whole problem. Okay, so here we go. So positive plate, negative plate. First thing you want to do when you're doing a circuit problem, you got to simplify it down. These 3 resistors right here are in series or parallel? Parallel. And dudes, you got to know the 2 things that are true for series and the 2 things that are true for parallel. What are the 2 things you have to know for parallel? The current that goes through each of these is what? The same or different? Different, but the voltage across each of them is the same, as we just said. Those are the 2 things to know about parallel. And then what are the 2 things to know about series? If you have resistors that are in series, what do we know about resistors in series? Like boom, boom, boom. These 3 resistors would have the same current. The current that goes through them is the same, just like water through a pipe. But the voltage, the delta V across each of them would be different. Because, delta V equals IR. So different current. If these were different resistors, say this one here was like 2 ohm, 4 ohm, 6 ohm, something like that. Okay? All right. So how do you simplify resistors in parallel? So we're going to simplify these three into one. So you got to do the 1 over equation. So here's what it's going to look like. So this simplifies to 3. When you do the algebra, that's 3, and then this guy's 12, right? Still a 30-volt battery. Okay? Yo. Oh, where I got the 3 from? Sure. Let me show you where, I'll show you where I got the 3. So for these 3 guys here, so for these 3 resistors here, you go like this. You go 1 over the equivalent. 1 over the equivalent resistance is 1 over 18 plus 1 over 9 plus 1 over 6. So you do that on your calculator, and what that's going to give you is 0.33 repeating. Now, is that the equivalent resistance, or is that 1 over? That's 1 over. So you got to cross multiply, or you could just flip both sides. So the algebra would be the equivalent is 1 over 0.33 repeating, which gives 3. Like that. Yo.
Or basically, the common, you figure out the common denominator, which is 18.
Yeah, you can do that. Yeah.
Like 18.
This is 2 over 18. This would be 3 over 18. So you add these all up. That's going to be 6 over 18, and then flip it. So then the equivalent would be 18 over 6.
Oh.
Yep, you could do that.
Which simplifies to 3.
To 3.
That's what I did.
Okay. Now, so moving on. So we have this diagram now, and then let's just simplify it again. So to simplify this again, how do you simplify a 12 and a 3 in series? These are in series. You add them. So that's 15 ohms, 30 volt. Okay, now let's label our currents. Let's call the current out of the battery. The current out of the battery is I1, right? So I1 goes around like this. It's the current before splitting. There's I1. And then up here, we'll call this I2. And then through here would be I3. And then down here will be I4. And then what's this one going to be? We're back to I1. Okay, what current is in this picture? I1. 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 It's the current before splitting. Okay, what current is in this picture? I1. I1. Okay, so we've answered the first question. The equivalent resistance of the whole circuit is 15 ohms. Now, the next question. Calculate the total current out of the battery. What did we label that? The total current out of the battery. That's I1. Now, are we going to use this picture to get I1? I wouldn't. In fact, we can't, because we don't know. Like, do we know what the delta V is across this guy yet? So we're not going to use this picture. The picture to use is the last one, because what must be the delta V across this 15? The delta V across this, what must it be? 30, because right here is what? 30, and then the other side is 0, right? 30 and 0. Okay, so I1 is going to be, so we're using Ohm's law. Let me show. So Ohm's law is delta V equals IR, right? So rearrange that. I is delta V over R. So it's 30 volts over 15 ohms, which gives 2 amps. So that's I1. And then over here, this is 2 amps. and this is 2 amps. Everywhere that we have I1, it's 2 amps. Okay? All right, next question. Calculate the voltage across each resistor in the circuit. Okay, so let's do it. The delta V, the voltage is delta V. See how far I can clean this up. That's it, okay. Okay, so finding the delta V's in the circuit. Okay, so anyway, I put it back 2 amps. So let's start with this guy. Guys, what would the delta V be across this guy, the 12 ohm? Can we figure it out? Delta V equals IR. What's the current in that resistor? 2. What's the resistance?
12 ohms.
12 ohms, so 2 times 12 is 24. The delta V is 24. Yo.
Just wondering, are resistances the only thing that you can directly add together? Like you can't add like the currents of 2 resistors together?
No, you wouldn't want to add the currents together. Like, so for example here, 2 amps and 2 amps. You wouldn't be like, oh, 2 amps and 2 amps is 4 amps. You wouldn't do that. No. But you add their resistances together. That's true. Okay, how do we figure out the voltages across these guys? The 18, the 9, and the 6. Now look, guys, you could actually figure it out from this diagram. You could. Look, 30-volt battery, 0 and 30, right? So over here we got what? 0. Well, look, if the delta V is 24 across this resistor, so 0, so what must this point be? 24. In order for the delta V to be 24 there? And then look, what's this point right here? 30. So you could figure out, we're like, okay, 30 and 24, so use your subtraction skills. 6. Each of these must be 6 volts. Now let's pretend you didn't realize that. Let's say, so I'll show you another way. What you could do is you could go to this guy. Who is this guy right here? Who is this guy? He's these guys, isn't he? So if you can find the delta V across that guy, then you found the delta V across these guys. Because this guy, this guy right here, is these guys. Simplified. So what's the delta V over here?
6 volts.
6, because you go, delta V equals IR. What's the current through that resistor? 2, and then the resistance is 3. 2 times 3 is 6. So that's another way to do it. So anyway, that answers number 5. The voltage is across, so it's 24, 6, 6, and 6. Ooh. I gotta change this worksheet. That's evil. 6, 6, and 6.
Why you say it's
Bad, dude. Bad.
That's only history.
Triple 6.
That's only history.
Okay. I'm gonna change it, dude. I'm changing it.
Why you say that?
Okay. Next question. Shh. Next question. Okay. Calculate the current through the 18 ohm resistor. We're almost done here. Almost done. The current through the 18 ohm. How do we get the current through this guy up there? How do we do it? Well, okay. Delta V equals IR. So I is delta V over R, right? The resistance is 18, right? What's the delta V across that resistor? 6, right? Because we're going, you go from 30 over to 24, and the change is 6. So this is going to be 0.3 repeating. That's the answer to that question. The current through the 18 ohm is 0.3 repeating. All right, then last question. How much energy does this circuit use in 7 minutes? Okay, this is a 2-part problem, guys. fact, I'm going to do some big time erasing here. All we need is the last picture. Let's get rid of that. We don't even need this anymore. All we need is the last picture. So looking at this last picture, this picture represents our total circuit. That represents everything. How much energy does this circuit use in 7 minutes? So what's the first thing we got to calculate? Nathan?
The power.
The power. So you got these power equations. P equals I delta V. P equals delta V squared over R. P equals I squared R. And I'll give those to you on the quiz. Okay. So those are the power equations. Which one can we use? Actually, any of them. Because we know everything. Look at, we know everything about this diagram. What's the delta V on this diagram? 30. What's the resistance in this diagram? 15. What's the current? 2. So look, you get the same answer no matter what. So do P equals I delta V. You're going to get what? 60. Okay, do this one. V squared over R. V squared, that's going to be 900 over 15. Guess what that is? 60 watts. Okay, I squared R. What's I squared? 4 times 15, 60. So no matter which one you use, you get the same answer. Now, how do we answer the question? The energy that this, in fact, you know what I'm telling you, you know what I was looking at right before you guys came in? So you know my travel trailer? My travel trailer, when I'm doing dry camping, I'm not hooked up to an electrical source, right? So I do my generator, and I basically have 2 car batteries that keep my lights on unless the generator's going. So the bulbs that are in there are not LED. So I want to say they're at like, I think they're like 15 watt bulbs, whereas the LED ones are like 3 watts. Same amount of light, but instead of 15 watts, it's 3 watts, which basically means what? It uses less energy. What does 15 watts mean? 15 joules per second. What does 3 watts mean? 3 joules per second. It's using less energy per second. So this is telling us, like 60 watts, that's 60 joules per second is what it means. So how do we figure out how much energy was used in 7 minutes? Well, first of all, so T equals 7 minutes, but we got to put that in what? Seconds. That's 420 seconds. 420? Got to change. I got to change that, dude. I got to change that. Okay. So, what's the definition of power? Power is energy over time. So energy is going to be P times T. Power is 60 watts. That's joules per second. The time is 420 seconds. Cancel that. So the energy used is 8. Wait, where is it? 25,200. 25,000. Yo.
Number 7, I was like first is confused because when I was trying to work out 7, I was focusing on number 6. Like, that.
Oh no, 6 and 7.